And we are going to prove why the 45-45-90 triangle method works. This is one of the two special right triangles that we're going to prove in this video. So the last videos, we've been learning that the answer for the hypotenuse, or some kind of answer, is going to have a radical 2 in it, like 7 radical 2, right here for this question mark. We also have, for question number 2, for the 10-10 for the hypotenuse, our x radical 2 is our 10 radical 2. But hang on, why does this happen? Well, if we go back to the formula, we should see that x here and x here is going to have a hypotenuse as x radical 2. But we have c. If we do the Pythagorean theorem as if we were trying to solve any kind of right triangle, rightly a right triangle, we use a squared plus b squared equals c squared. Turns out, whatever this thing is going to demonstrate how we get to our x radical 2. So instead, we have x squared plus x squared is going to equal our c squared. X squared plus x squared is going to represent 2x squared equals c squared. But there's going to be a little bit of a problem. What we are going to do now is square root the 2x squared and square root the c. We are going to move c on the bottom because that represents our hypotenuse right to this line. We're going to color it all the way in blue. Now, we have to do 2x squared and c squared. We already did our c right here. That is our hypotenuse. But then, we are going to have radical 2 and radical x squared. But x squared and the square root is going to cancel each other out. Therefore, if I get rid of the square root and get rid of the square, turns out that that x is itself. And then here's that radical 2 because that was the clutter that we never used. And voila! We proved that the hypotenuse is going to be x radical 2 if we have two congruent variables, segments right here. And that's why we kept getting to 10 radical 2, x radical 2, and 7 radical 2 in these two problems. So that is how we prove special right triangles. Thank you for watching Top Ping Analyze Math Industry. Like and subscribe.